Okay, so this here is a complex number. It's written in the form a plus bi, and this whole thing is the complex number, but there's different parts to it, as you can see here. So this a right here, where there's no I attached to it, that's the real part of the equation, or the expression. So let's say we have 4 plus 3i. 4 is just a normal number on the number line. It's a positive number, right? So that's the real part of the expression. Now 3i. 3i is the imaginary number, as you can see here, where here 3 is equal to b. And I is this right here. I is a square root of -1. And you might be thinking, but there's no square root to -1. Well, there is when you're talking about imaginary numbers. You can't have any real number and have that be a square root of a negative square root. So let's say we have -64. If we use only real numbers, there's going to be no answer to this, because no matter what numbers you try, nothing is going to be squared itself to equal -64. That's why we say this is 8i. That's what we use I for. Okay, so let's see how we're supposed to treat complex numbers like I. How are you supposed to treat it like a variable, like an exponent? How do you treat it? So it's very similar of how you treat radicals. So let's say we have 2 plus root 3 plus 4 plus 2 root 3. Obviously, you just simplify these two real numbers. So 2 plus 4, 6. And then technically there's a 1 here. So 1 plus 2 is 3. And then you don't multiply the radicals themselves. So it just becomes 6 plus 3. And then you stick with the root 3. And now with multiplication, it's a similar thing. You just FOIL the two binomials. You have 2 times 4 is 8. And then 2 times 2 root 3 is 4 root 3 plus 4 root 3, which is 8 root 3. And then 2 root 3 times root 3 is 2 times 3, which is 6. And then now with complex numbers, it's very similar with addition. Let's say, in this case, I is basically root 3. So 2 plus I plus 4 plus 2i is 6 plus 3i. And the only difference here is there's a root 3 and 3i. And now with multiplication, it's also similar, but this time it's a little different because I'll show you why here. 2 plus I times 4 plus 2i, same thing. We just replace root 3 with I. So 2 times 4 is 8. And then 2 times 2i is 4i. And then 4 times I is 4i. So both of them added is 8i. And then now 2i times I is 2i squared. But you can't leave it like that, because if you remember, I is root -1. And when you square it, let's say we square both sides, we have I squared equals root -1 squared. So when you square the radical, this thing goes away, and then you're just left with -1. So this is really 2 times -1. So that's why it's 8 plus 8i minus 2. So technically you could just write it like 6 plus 8i, and here 14 plus 8 root 3. But I just kept it here so you can see the difference of what happens when you multiply two imaginary numbers together. You'll get -1, depending on the exponent. Okay, so let's say if z is 1 plus I and w is -2 plus 3i, find z plus 2w. So let's do a first. So we know z is 1 plus I, so let's just write that here. 1 plus I plus 2w, and we already know what w is, which is -2 plus 3i. So 2 times -2 plus 3i. And now all we have to do is just simplify. So we have 1 plus I plus 2 times -2 is -4. So -4. And then 2 times 3i is 6i. So plus 6i. And now all we have to do is add similar numbers. So 1 minus 4 is -3. And then I plus 6i is 7i, so plus 7i. And that's the simplified version. And then now let's do part B. Now we have multiplication. Z squared times W. So again, we know what both of the variables are. So Z is 1 plus I. So we have 1 plus I squared times negative 2 plus 3i. So let's expand this a little. So 1 plus I, 1 plus I. And this is going to be 1 plus 2i, and then plus I squared. Now, we can quickly remove two terms from here because this is 1. This I squared is, remember, I is root negative 1. So root negative 1 squared is negative 1. So can you see this right here? 1 minus 1 is just 0. So you can just take both of these off. And then now, all we're saying now is 2i times negative 2 plus 3i. So this whole thing just simplified down to 2i, that quick. So now 2i times negative 2 is negative 4i. And then 2i times 3i is plus 6i squared. But once again, we have I squared, which is negative 1. So really, this becomes negative 6 minus 4i. Also, I flipped around this real number to be on the left because if you remember, complex numbers are in the form a plus bi. Where here, this is the real number and this is the imaginary number, a plus bi. Okay, so number 2 says simplify I over 1 minus 2i. So the first thing I'll do is just write out the equation or expression again. I over 1 minus 2i. So the first thing I'll do is just take a look at the denominator. So what we can do is take the conjugate of the denominator. So what I mean by the conjugate is, so first of all, we see this is written in a plus bi form. So a plus bi. The conjugate of a plus bi is just a minus bi. So here, the conjugate of 1 minus 2i is just 1 plus 2i. But be careful, this has to be in only a plus bi form. So let's say we had 4i plus 7. We can't just take the conjugate and say 4i minus 7. It has to be 7 plus 4i, and then you take the conjugate, which is, so this is wrong, this is right, this is right. There has to be 7 plus 4i, and then the conjugate is 7 minus 4i. So you have to start with a plus bi. You see how this is bi plus a, so that's why this doesn't work. Okay, so with that knowledge, let's actually simplify this now. Also, when we use a complex conjugate, we multiply not just the denominator, but we multiply the numerator as well. So we saw before, this is going to be 1 plus 2i, the conjugate. So I times 1 plus 2i over 1 plus 2i. And as you see, we're not changing the equation or expression at all because 1 plus 2i divided by 1 plus 2i is just 1. So you're just multiplying it by 1. Okay, now we can just multiply the numerator on top. So I times 1 is just I. And then I times 2i is negative 2 because remember 2i squared is negative 1. So 2 times negative 1 is negative 2 divided by 1 minus 2i times 1 plus 2i. So this should look a little familiar, difference of two squares. So 1 times 1 is just 1. And then we can ignore the middle part. So negative 2i times 2i is negative 4i squared. But negative 4i squared. But I squared is negative 1. So negative 4 times negative 1 is just going to be plus 4. And then now this simplifies to I minus 2 over 5. And now we can switch the numerator. So this becomes negative 2 plus I over 5 because we want to get a plus bi form. So we have a fraction. So what do we do with fractions when we want to get a plus bi? Because technically this is a plus bi over something else. And we want to get strictly a plus bi. What we can just do is split this fraction apart. So we just get negative 2 over 5 plus I over 5. And now we have it in a plus bi form, even though it's in fraction. But this counts because this technically is a real number, and this is the imaginary number, and it's in two different terms. So this is a simplified version.